Okay guys, this is the third topic of Unit 6, GCF. So GCF stands for greatest common factor. So let's write that, greatest common factor. So for example, if I was to give you two numbers, let's say 5 and 15, what is the greatest factor that can come out of 5 and 15? The GCF would equal 5 because 5 divided by 5 is 1 and 15 divided by 5 is 3. That's the biggest number that we can take out of both those numbers. So that's what GCF means. Except now we're looking at GCF not at numbers but at our polynomials, just like we've been learning this week, all about polynomials. Okay, so let's look at the first example here. We need to see what is the biggest term we can take out of all three terms. Okay, so we have a 20, a negative 35, and a negative 20. So those are our coefficients. Then we have an n squared and an n cubed. Notice that this first term right here doesn't have an n, so that means we can't take an n out. If not every term has it, we can't take it out. So right now we're just looking at numbers. Okay, so let's look at 20. We know all the numbers that can go into 20. We even write them off to the side if you want to do that. All the numbers that can go into 20 are 1, 2, 4, 5, 10, and 20. 20 is divisible by all of those numbers. Okay, let's check 35. 35 is divisible by 1, 5, 7, and 35. So we need to find the biggest number they have in common, and the biggest they have in common is that 5. So we're going to take out a 5 from every single term. So I'm going to write 5, and then some parentheses. So 20 divided by 5 is 4. Negative 35 divided by 5 is negative 7n squared, because we bring that down. Negative 20 divided by 5 is negative 4n cubed. That is our answer. We can only take out a 5. That is the GCF. This right here is the GCF. Okay. Cool. Now let's look at the problem below. Okay. So we have 3 coefficients, and we also have a variable for each one, meaning we can take out a coefficient and a variable. So let's write our numbers off to the side. 3, 15, and 6. Okay, the numbers that can go into 3 are 1 and 3. The numbers that can go into 15 are 1, 3, 5, and 15. The numbers that can go into 6 are 1, 2, 3, and 6. So that means the biggest number that can go into each of them is 3. So we're going to factor out a 3. Okay, let's do the same with our k's. We have k cubed, k squared, and k. Remember, k cubed is k 3 times. K squared is k 2 times. This is k. What's the biggest number we can take out of both? Only 1. We can only take out 1k. So we're going to take out 3k from everything. So 3k, then we do our parentheses. So negative 3 divided by 3 is negative 1. K cubed divided by k is k squared. 15 divided by 3 is 5. K squared divided by k is k. Negative 6 divided by 3 is negative 2. And k divided by k is just 1, so we don't have to write it. So this is our answer. And this all pulls from the properties of exponent that we learned in Unit 5. So let me write a note off to the side that Unit 5 which was the properties of exponents. Properties of exponents. Remember that if we are multiplying common bases, so x to the a times x to the b, we add them, x to the a plus b. And if we're dividing common bases, x to the a divided by x to the b, we subtract them, x to the a minus b. So we're using this, and that's how I found my my variables right here. That's how I found the exponent for each one. Okay, let's look at example 3. Okay, example 3, we have coefficients for each one, and we also have variables for each one. So that means we're taking out coefficients and variables. Okay, so let's look at our numbers. We have 9, 63, and 90. Okay, so all the numbers that can go into 9 are 1 and 9. All the numbers that can go into 63 are 1, 7, 9, and 63. And all the numbers that can go into 90 are 1, 2, 3. This list goes on and on and on and on and on. But what is the biggest number we can take out of each one? And that would be 9. 9 is the biggest number we can take out of each of them. Okay, let's do the same with our x's. So I have x to the 6, x to the 3, and x to the 2. Remember, that means we write the x's that many times. So this one's 6 times. 1, 2, 3, 4, 5, 6. This one's 3, and this one's 2. We can only take out as many x's as the smallest amount of x's. So that means we can take out 2 from each one. That's the greatest common factor. So that means we're taking out 9x squared. 9x squared. Okay, let's do our parentheses. Now we're dividing. 9 divided by 9 is 1. X to the 6 divided by x squared is x to the 4th. Remember, we subtract. 63 divided by 9 is 7. X to the 3 divided by x to the 2 is x. 90 divided by 9 is 10. And x squared divided by x squared is 1, so we don't have to write it. So this is our answer. And let's say this is a little confusing to you. You're not sure if this is the correct answer. What we can do is that we can distribute this back in, just like how we learned how to do yesterday. And you can double check your answer by multiplying each of these terms. So for example, let me do it backwards so you can see. 9 times 1 is 9. X squared times x to the 4th is x to the 6th. 9 times negative 7 is negative 63. X squared times x is x cubed. 9 times negative 10 is negative 90. X squared times nothing is x squared. Notice how this answer is exactly the problem that we started with. So it's just a way to double check. Okay, let's look at the last example. Okay, so in the last example, notice that they have coefficients for each one, but not every one has a variable. This one's missing a variable. So that means the only thing we're pulling out is a number. So we have 50 and 20. So all the numbers that can go into 50 are 1, 2, 5, 10, and 50. And all the numbers that can go into 20 are 1, 2, 4, 5, 10, 20. I might be missing numbers in here, but that's okay. We just need to find the biggest number that they both have in common. And they both have a 10 in common. So that means we're going to be taking a 10 out of this expression. So let's start dividing. 50 divided by 10 is 5. p cubed, because we didn't take out any p's, so we can just rewrite them. 50 divided by 10 is 5p squared. And negative 20 divided by 10 is negative 2. So that's our answer. Remember, if you want to double check, you can distribute this back in, and you would get the exact same answer that we got in our problem. Okay, now you guys are working on the worksheet, and I will be back tomorrow, so make sure all of these are done and ready to turn in on Friday.